guys, this is Mrs. Tran-Bloom. We are going to pick up on example 3 of section, excuse me, 3.3. Now, keep in mind that 3.3, we're going to look for the same exact thing as 3.1 and 3.2, which is the slope of any function, right? Or the slope of the tangent line of any function. But in 3.3, we are now able to do it in a much easier way. Okay, so we're going to start with example 3. Okay, so example 3 says find the tangent, okay, to the curve y equals x to the third plus x at the point where the slope is 4. So it's giving us the slope. What is the smallest slope of the curve? And what values of x does the curve have this slope? So if you look at this, there's a couple of things. It says find the tangent. Okay, so let's call this part A. What is the smallest slope? Let's call this part B. And what are all the values of x? Okay, so let's call it part C. Just so like when I'm in the little bit, I can sort of write it in a way that it's going to be neat and organized. So part A, let me get maybe a pencil, okay? Part A says find the tangent to the curve, okay, when the slope is 4. We have the slope, okay? We have the slope, which is m equals 4, which is y prime, okay, or the derivative of f of x. We now need a point, okay? Because to write an equation, find the tangent, which is mean, by the way, find the tangent to the curve, meaning that you're going to write an equation, okay, of a line, because it says the slope. Oops, can you see that? Okay, so find the tangent to the curve means you're going to write an equation of a line, especially in this case we know it's a line because it's given us a slope. So we have the slope of m equals 4, which is the same thing as y prime, which is the same thing as the derivative with respect to x. Okay, so we now need a point. So the first thing I'm going to do is take the derivative of this curve. So y prime equals f prime of x. Okay. Now that we have learned the quick, easy way of taking the derivative, that's what I'm going to use. So x to the third, taking the derivative of that is 3x, and I'm going to subtract the power. So 3 subtract 1 is going to be the power of 2. And the derivative of a line is going to be 1. So this is the derivative of x to the first power. So bring down the power, which is 1. And then subtract the power of 1. 1 minus 1 is x to the 0. X to the 0 is always 1. Okay, so now that I have a derivative of the curve, I'm going to set it equals to my 4. Because that's the slope. And this is the slope of all x's. So now we're just going to solve for x, okay? I'm going to move 1 to both sides. How about if I'm going to need a lot of space. And so what I'm going to do is I'm just going to work with this space for A. And in this space, we'll probably do B and C. So I'm going to move 1 to both sides. So I have 3x squared equals 3. I'm going to divide both sides by 3. So I have x squared equals 1. So now I'm going to solve for x. So I'm going to take the square root to both sides. X is going to come out to be a plus 1 and a minus 1. Okay? Whenever you're taking the square root, you need a positive and a negative. Well, I have the x coordinates. Now I need y coordinates. So to get y coordinate of the point, I'm going to enter it back into my original equation. So we're going to do y equals f of x, which is really, I'm going to do f of 1 first. Okay? So we have 1 to the third plus 1, which is going to be a 2. So my first point is 1 positive 2. Right? So y equals f of x, which is f of negative 1 equals. I'm going to enter negative 1 to the third. All right. Plus, oops, my pencil broke. Plus, oh man. All right. Plus negative 1. Okay. Negative 1 to the third is still negative, and then you're going to add a negative. It's going to be larger negative. It's going to be negative 2. So my second point is negative 1 comma negative 2. So notice how the slope of 4, it's at 2 different points. Okay, and that's okay. I'm just going to touch at each location. So it's still going to be a tangent. So to write an equation of a line or find the tangents, I'm going to write y minus 2 equals, So y take away y sub 1 equals the slope, which is 4, times x take away x sub 1, which is x minus 1. I'm using this point first. So y minus 2, you know what, I'm just going to distribute and bring the 2 over, alright? So y equals 4x. 4 times negative 1 is going to be negative 4. Bring the 2 over, so let's add 2. So I'm trying to write small here, so I'm going to zoom in. The reason I'm trying to write small is because I didn't really give myself a lot of space, okay? So my first line is y equals 4x minus 2, and box that up. Okay, that's the equation of my first tangent. Similarly, I'm going to do the other side. Y, take away y sub 1, which is going to take away a negative 2, equals the slope times x take away my x sub 1. Okay, so this is becoming a positive, that's also becoming a positive, so y equals 4 times x is 4x. 4, that's positive. And so 4 times a positive 1 is going to be positive 4. Okay, so plus 4. And this is also going to become positive. And then I'm going to subtract 2 to this side. So y equals 4x. 4 take away 2 is going to be positive 2. So those are my two tangents when the slope is 4. Okay, so that's part A, now that we're kind of labeling the pieces. Alright, part B, what is the smallest slope of the curve? And what x values is it that this smallest slope is located? Okay, so B and C, we're going to do it together in one place. So I'm going to move it right here. Okay, we are going to put B and C together. They're related, alright? So we have the slope equation of all x, which is y prime, which is the same thing as f of x prime, equal to, or f prime of x equals to this piece, 3x squared plus 1. Okay, this is an equation or a function of all slopes. Okay, I mean for all x. This is a function of a slope of all x. So what I'm going to do first is I want to find the smallest slope. Okay, that means I want to find the smallest y prime. So I'm just going to graph it out. To graph this out, the vertex, and I do expect you to be able to graph the simple functions such as this one. The vertex is going to be at 0, comma 1. Okay, so let's quickly sketch this out. It opens up, so I know I don't need a lot of negative y values. 1, 2, 3, 4, 2, 3, 1, 2, 3, 4, 5. Alright, so when x is 0, y is 1, so that's my vertex. And when x is 1, I'm just going to pick a value on the right. 1 squared is 1, times 3 is 3, plus 1 is 4. So 1, 2, 3, 4. It's going to be symmetrical, so I don't need to do anything else except mirror image with the vertex. So here is the graph of all x values, or the slope, okay, for all x values. Okay, so the smallest y prime, which is the smallest slope, it's the vertex. Okay, so in this case, y prime equals to 1. Okay, so I'm going to spell it as smallest slope is when y prime is 1. Okay, now what location? Because part B says at what x values does the curve have this slope? Well, when x is 1. When x is 1. So both parts B and C, oops, can you see that? Both part B and C are related to each other. One is just asking what the slope is, and one is asking the location of this particular slope. So I'm going to leave that up for you guys to copy. Alright, now if you are still copying, just go ahead and hit pause, because I'm just going to move up to example number 4. Example number 4. Find the x and y intercepts of the line that is tangent to the curve y equals x to the third at a particular point, -2, -8. Okay, so to find the x and y intercept, obviously I would need to locate this line. So let's find first, I'm going to spell it out. To find the x and y-intercept of the line, we need the line. Okay? To find x and y-intercepts of the line, we need to find the line first. We need to find the line first. Okay? They gave us the point, now we need the slope. So to get the slope, we need to, so second, find slope, find m, which is y prime, which is f prime of x, okay, which is d over dx. One of those is exactly the same thing. So we're going to find the f prime, okay, so y prime, which is of this curve, x to the third, which I'm going to bring down the power of 3, and then I'm going to multiply to x. I'm going to subtract the exponent, so 3 minus 1 is going to be 2. This is the slope for this curve at any value of x. So now I want it at the x value of -2. So now we're going to plug in -2. Plug in x equals -2 to get a y value, because I need to have an equation of a line, which I have a point, but I need a slope. Okay, so here we go. M equals y prime, which is 3 times -2 squared, which is 4. 4 times 3 is 12, which is my slope. See that right there? So now I'm just going to write an equation of a line. So here we go. So 3, or third step, line. Okay, y, take away y sub 1, which is going to be a negative of -8 equals slope, which is 12, times x, take away x sub 1, so x take away -2. Okay, these two will become positive. Alright, so that's going to give me y equals 12 times x is 12x. 12 times a positive 2 is going to be a positive 24. Take away 8. So this is going to give me a line at 12x. That is going to be what? 16, right? Positive 16. Ooh, there you go. Ooh, there you go. Moving over. So that's my line. Okay, that's my tangent line. So tangent line to that particular point, or at that particular point. So to find the y-intercept, that's super easy. Y is just going to be 16. So when x is 0, y is 16. Box it up, because that's what I'm looking for. X-intercept is when y is 0, so let's find out. I'm going to set y equals to 0 equals 12x plus 16. Move the 16 over, so -16 equals 12x. We're going to divide both sides by 12, so -16 divided by 12 equals x. Can I reduce that? Divide top and bottom by 4. So x is going to be -4 over 3, and that is my y. I'm sorry, that's my x-intercept. Let's write that as a point, order pair. When x is -4 over 3, y was 0. Alright, these two are the same exact thing. This is a notation in terms of a point. This is notation in terms of value. Okay, now if that's going too fast for you, please hit pause and finish writing before we move on to the product rule. Alright, we're going to move on to another edition of our theorem. Product rule says let u and v be two distinct functions of x. Okay, that means with respect to x variable. Then d over dx, or the derivative with respect to x of the product. I'm going to take the u function times the v function, or you can just write u, v next to each other, equals to, here we go. It's not the same thing as addition, how we took the derivative of one function and we took the derivative of another function and we added together. So please remember that we cannot take the derivative of one function and the derivative of another and multiply. we would have to first take the derivative of the first one, multiply to a regular function of v. Then we're going to add it to, we're going to take the derivative of the second, we're going to multiply to the first. Okay? So take the derivative of the first function, multiply to the second. Add it to take the derivative of the second, multiply to the first. Your textbook has this. I'm sorry, not your textbook. Your textbooks has v and u. Other textbook would have something like this, f and g. Okay, so it's the same thing. We're going to take derivative of the first, multiply to the second. We're going to add it to the derivative of the second, multiply to the first. All right. All right. So we're going to do this piece right here on the bottom. We're going to go to example 5. And again, if you need more time to write the product rule, just hit pause before and then move on to this example 5. Example 5, the product rule is useful when finding, okay, f prime of x if f of x equals the product of x times radical for x minus 1. Since we don't know the chain rule yet, which we will learn soon, let's practice this type of derivative with a simpler example. So right now we can't do this yet, but we can do this piece, okay? I'm giving you a function, f of x equals u times v. Okay, so let u equals x squared plus 1 and let v equals x third plus 3. Now, if I were you, you're learning this for the very first time, okay? When you are using the product rule, write it out every time, even including the product rule itself. So the product rule says, okay, so the product rule says that f prime of x or d over dx, okay, we're going to do u prime times v. Okay, so let's take the derivative of the first times the second, add it to the derivative of the second times the first. So it looks like I would need u prime and v prime in this formula. So what I'm going to do next, I'm going to do u prime. Okay, u prime is going to be 2x. I'm going to subtract the exponent, which is to the 1, which is now just 2x. Derivative of any constant is 0. V prime is going to be 3x squared, and the derivative of a constant, again, is going to be 0. So now I have u and u prime. I'm just going to plug it into this equation. So this one said I'm going to take u prime, which is now 2x, times my second, which is this whole piece right here, which is x to the third, plus 3, add it to the derivative of v, which is 3x squared, times my first original, which is x squared, plus 1. And yes, you do have to distribute or combine like terms. So here we go. 2x times x to the third is going to be 2x to the fourth. 2x times 3 is going to be 6x. We're going to distribute this out. That's going to give me 3x to the fourth. 3x squared times 1 is going to be 3x squared, because I'm just going to multiply by 1, which is its identity. So write it in the highest power to see if you can combine. Oh, I can combine those. So that's going to give me 5x to the fourth. The next one is plus 3x squared. Bring down my positive 6x. And looks like, did I add it right? Let's double check, right? Let's see. I want to double check my equations, okay? I have 2x here. 2x to the third. My u is going to be this piece. Double check all your work. This is u, which is x squared plus 1. So u prime, which is simply be 2x. My v is x to the third plus 3. So v prime is simply 3x squared. Okay. So u prime, which is 2x, bring it here, times v, which is x squared plus 3. So that's that piece. V prime is simply 3x squared times u, which is x squared plus 1, distribute. 2x times x to the third is 2x to the fourth. 2x times 3 is 6x. 3x squared times x is 3x to the fourth. 3x squared times 1 is itself. Combine that and that, that's 5x to the fourth. move this over here and move that there. So this is the derivative of f. Alright, pause it if you need to finish copying. And you know what? Let's just end right here. Alright, it's a good spot. Alright, I'll see you guys in class.